An experimental setup used in school laboratory to determine the surface tension of a liquid is shown figure 1. Part A 1. Figure 2 shows enlarged view of the vertical projection of capillary tube along the axis. Draw the meniscus of the liquid inside the capillary tube and indicate the surface tension T and contact angle theta between the liquid and glass surface of the capillary tube. In figure, they have given that it is a liquid. They have not specially given it is a liquid like mercury. Therefore, we have to draw the normal meniscus. It means meniscus like in water. We can draw meniscus and we have to indicate surface tension. Surface tension is in this direction. It is tangent drawn to the fluid surface, liquid surface at this space. Surface tension. And contact angle is the angle between tangent and solid surface through the liquid. There are two angles between tangent and solid surface, this angle and this one. We have to get angle through the liquid. We can mark this surface tension for all sides along the this meniscus, but we have to draw only one surface tension and angle for only one point of the surface. Then part 2 is the height of the liquid column in the capillary tube, the inner radius of the capillary tube and density of the liquid are H, R, rho respectively. Obtain an expression for H, rho, G in terms of T, R and theta. We have to write the expression for the capillary height. When writing capillary height, we know that H rho G equals to 2T cos theta over. We have to subject H rho G because of they have asked an expression for H rho G. Then part 3, clearly writing the assumption made show that the equation obtained in part 2 above can be reduced to H equals 2T over R rho G. The given equation in part 3 is like this. H equals 2T over R rho G. 2T over R rho G. It means cos theta has been removed. When removing cos theta, value of cos theta should be 1. Value of cos theta should be 1. We know that cos value is 1 for 0 degree. Therefore, we have to assume that contact angle for given liquid and solid surface is 0. The assumption is contact angle between given liquid and glass. So it is given as glass in this experiment is 0. It is the assumption. Then part 4. In order to satisfy the assumption mentioned in part 3 above, for the given liquid, write down experimental procedure that should be followed in the correct order. We have to get the contact angle 0 position. When getting contact angle 0 position, we have to get pure water and pure glass. We know that contact angle between pure water and pure gas is 0. We can clean the gas to get the contact angle 0. When cleaning gas tube, we have to use a dilute base first, then acid, and finally with pure water to clean the gas surface. Then we have to write answer for part 4. Clean the gas tube by using a base first and an acid, then finally by pure water. Or we can write clean the gas tube using an acid, a base, and again an acid, and finally water. Then part 5, before taking the readings required to determine the height h. What is the adjustment to be made in the experimental setup shown in figure 1? We have to get the capillary height. Capillary height means the height between this surface and this position. In the given experimental setup, they have given a pointer like this. The pointer. We have to adjust the lat jack such that this liquid surface is touching pointer. Then we can write part 5, adjust the lat jack such that the pointer touches the fluid surface. It is the adjustment we have to do before taking H measurement. Then we can adjust cavity microscope to this place and this tip of pointer, and then we can find capillary height by using 2 readings. We have to get the difference between 2 readings of cavity microscope. Or we can use directly meter scale, meter ruler, or meter scale with tube to obtain this height. Then part B. The following graph shows the experimental data in SI unit obtained using 6 capillary tubes with different radii and radii to determine the surface tension of water. Part 1. Considering the equation in part A3 above. A3 means this equation. Identify and write down independent variable x and dependent variable y of the graph. We have to use radius as the independent variable because of we are changing radius. Then we have to write the physical quantity with radius to the x-axis. We have to use independent variable to the x-axis, and we are measuring x value corresponding to the radius of capillary tube. We are changing this simple R value and we are measuring H value. Then H value should be the physical quantity represented in y-axis. Then we can rearrange this equation. We have to subject H, it is for y-axis, and we can get R term separately. 2t over rho g times 1 over R. Now it is in y equals mx form. Then we can write, for x-axis we have to get 1 over R. For y-axis we have to get H. It is the answer for B part 1. Then part 2, determine the surface tension of water using the graph and state the answer with SI unit. Density of water is 1000 kilograms per cubic meter. We have to obtain the gradient of the graph. We know that gradient of the graph is equal to this term. Gradient equal 2t over rho g. When finding gradient, we have to get difference of y divided by difference of x for 2 points of the graph. Now we have to consider 2 points of the graph. When getting 2 points in a graph, we have to consider 2 points in this marked region. It is the first condition. And we have to get 2 points with the maximum distance. It is the second condition. And we have to obtain 2 points. We can read clearly x and y values. It means the graph should be intersected small squares for corresponding 2 points. Then we can get from this end and this end we have to decide 2 points such that the graph is intersecting small square. But we can't obtain points we have used to draw the graph. There are 4 main conditions in getting 2 points to find the gradient. First one is we have to get 2 points in this region. We can't get points points after these 2 points. Then we have to get 2 points in this region. It is the first condition. Second condition is we have to get 2 points with maximum distance. Third condition is we have to obtain intersection points with graph and small square. It means we can identify x and y values clearly. Fourth condition is we can't get marked points. We have to get another 2 points. According to that condition, we can get 2 points of the graph. We have to refer the graph. We can get coordinates of this point. X coordinate 2.450 and y coordinate 26.5. 26.5. For this point, x coordinate 1.025, y coordinate 6.5. But when reading the graph, we have to consider calibrated values in x and y axis. They have given that y value multiplied by 10 to the power 3, x value multiplied by 10 to the power minus 3. No, x value multiplied by 10 to the power 3, y value multiplied by 10 to the power minus 3. Then we have to get points with this 10 to the power value. Then I will write difference of y. When getting difference of y, we have to subtract these 2 points. 26.5 minus 6.5, 20. We have to put 10 to the power minus 3. Divide by difference of x. We have to subtract this point and this point. 6 minus 5, 1. 5 minus 2, 3. 4 minus 0, 4. 2 minus 1, 1. Into 10 to the power 3. It should be equals to 2t over. They have given that density of water is 1000, G value is 10. Now we can simplify it. We can cancel out 10 to the power 3 with 1000. Then I will subject t 20 into 10 to the power minus 3 into 10 divided by 1.431. We can cancel out 2 10 to the power minus 2 with 10 to the power 2, then 10 to the power minus 1. Then we can get the simplified answer. It should be approximately equals to 7.02 into 10 to the power minus 2. Surface tension in Newton per meter. Then part 3. What would happen to the capillary rise if soap water is used instead of water? Briefly explain the answer. We know that if we are using soap water, surface tension is decreasing. Surface tension of soap water is less than surface tension of water. Then surface tension is decreasing according to this equation. When surface tension is decreasing, capillary height is decreasing. Therefore, H is decreasing. You are writing words when decreasing, when using soap water. Surface tension of soap water is smaller than water. Therefore, capillary height should be a small value relative to water.